Okay, we're still trying to find, I love this, the area of an isosceles triangle. And they say, find the area of an isosceles trapezoid, with the bases of 12 and 20, and the pair of base angles that measure 60. So here I have, and I'm going to draw it out, an isosceles trapezoid. Now, if that's an isosceles trapezoid, where are going to be your 60-degree angles? The top or the bottom ones? Right here. Yeah, they're going to both be right here, right? The bottom. All right. And they tell you the bases are 12, and this whole thing is 20. Okay? Now, I'm going to use to the advantage that I'm going to drop in my height. But I'm going to do it in two spots to make two congruent right triangles. When I do that, I know this is 12. Okay? If I do that and that is 12, what's left for these two to add up to? All right? They're going to add up to 8, first of all, because 20 minus 12 is 8, and they would have to be the same size, correct? So doesn't that make them both 4? All right. So now, looking at this, I need to find the height. Look, I have a 30, 60, 90 triangle. Which side do I know? Oh, look, I know the short leg. I need to get to the long leg. What do I multiply by? Root 3. So that's 4, root 3. There's your height. So when I work with it, again, we just write a formula. The sum of the bases times the height over 2. The bases are 12 plus 20. The height is 4 root 3 all over 2. So I get 32 times 4 root 3 over 2, just using my order of operations. And you should get, if you're working this correctly, I'm going to have to go to the right for space reasons, is going to be what? 64 root 3 square units. So that's your area. It's not that bad to do, but you have to make sure you work it out. Okay, now the next one is kind of cool. Remember, rhombuses and kites don't have a relationship in the sense that they're both parallelograms. A rhombus is a parallelogram. A kite doesn't have any pairs of parallel sides, just pairs of congruent sides. But one thing they do have in common is they have perpendicular diagonals. Both have perpendicular diagonals. Now, this next formula is a time saver. What it does is it helps us calculate formulas for rhombuses and kites that would otherwise take time because we'd have to either find sides or bases. It's just a time saver, and it's because you can really use the concept of that I could divide and conquer and get 4 separate triangles and add them together, and I can get 4 separate triangles and I could add them together. So we don't want to have to do that. So we have a formula that saves us time. But when they say diagonals, they mean this whole side's a diagonal. This whole diagonal length. This whole diagonal. And then I want this whole diagonal length. So when I say diagonal 1 and diagonal 2, those represent that. But they want the whole diagonal lengths with it. Well, the formula you use, 2 different ways of writing, is 1/2 diagonal 1 times diagonal 2. Or my preference, right here, area equals diagonal 1 times diagonal 2 all over 2. Do not add. Here do I want to do not add D1 and D2. Okay? Now, those are subscripts. Do not put them above. All right? Do not add those. They save time. But here's the key thing. Did you notice on the diagram, what did I mark for both of those? They're right angles, because I know those properties of their diagonals, and so that helps me huge. So here's the first easy one to do with a kite. If I have a kite here, I need to be able to figure out its area. Now I'm letting it be a little bit easier with the kite this time because I want you just to get used to the formula. But the area of a kite is diagonal 1 times diagonal 2 all over 2. So now let's do the lengths of the diagonals. Let's this one be diagonal 1. What's the total length of diagonal 1? That's going to be 20. So I get 20 times what? What's the length of diagonal 2? I'll just do the diagonal this way. Total length, that's right, it's going to be 16. So I just plug it in. All divided by 2. So that should be 160 square centimeters. Now, I'm not doing this, but this will show up on homework, quizzes, and tests. Don't be surprised if a right triangle shows up in there. Like a Pythagorean triple, or 45, 45, 90, or 35, 35, 35, 35, that's a new one. 30, 60, 90. Now, doing the same type of idea here, We get area equals diagonal 1 times diagonal 2 all over 2. Now, what's the length of diagonal 1? Well, they tell us that is 9. What's the length of diagonal 2? Tells us 12. All over 2. So it'd be basically 54 square feet. Now, I made these easy just for time-wise because plugging and chugging the formula. But I'm going to show you how rhombuses are used for this and how we can apply that to this formula. Okay, first things first, if you know you have a rhombus, you should probably mark all your sides congruent, but what's the next thing you're always going to do with every single one of your diagonals? What's the one thing for sure I'm going to mark? I'm going to mark the fact that they're perpendicular. So that helps me remember I can use this formula. Then I have to know the lengths. Now this one is length 9 and this segment is length 5. How in the world is that going to help me find all the diagonals? Think about properties. Is a rhombus a parallelogram? Yeah. The diagonals, besides being perpendicular, bisect each other. Right? So that means these two are the same and these two segments are the same. So now that means I should be able to figure out the length of the two diagonals because I know this would have to be 9, this would have to be 5, and now I can just add them together to get their total lengths. So my area is diagonal 1 times diagonal 2 over 2. Well, the length of one diagonal is 10. The length of the other diagonal is 18. That's all over 2. And if you plug it in, that's 90 square units. Not too bad. But notice I had to use a property of a parallelogram. Now, I'm actually going to use that property again for the next one. Because right away I'm like, ooh, I know those two are the same. And isn't it true that these two would have to be the same? Alright, so I know the length of one diagonal I can get to be 24. How in the world am I going to solve for the other one? Hopefully right now someone's going, ooh, 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 I know. Does anyone see a triple here? That is a 9, 12, 15 triple. So that's just a Pythagorean triple. Smiley face, that's how it saves us time. Well, that means I automatically know this other one is 9. So I plug in the diagonals again, diagonal 1 times diagonal 2 over 2. The whole length, I got 24 times 18 all over 2. It's going to be 216 square meters. There's your area. Now, how about the next one? Any suggestions here? Do I still use the fact that diagonals bisect each other? Oh yeah. Oh, but look, this is probably not even drawn into scale here. I know it's going to be a 45, 45, 90. So this one's 3. Because that's a 45, 45, 90. 3. 3. I get the length. So you just plug it in. Diagonal 1 times diagonal 2 over 2. End up being 6 times 6 over 2. That gives me 18 square meters. Hopefully that gives you an idea how to do those. This one was just using an isosceles right triangle.